Good. Matrices. Um, and as you know, this is online lesson, and we ask that you give us your cooperation. Just exercise patience with what we do. I'm very sure that at the end, you all be able to understand something. If you do not, then we can also help you out alongside. So, okay, I hope you can all see it clearly. Benoni, can you see it clearly?
Yes, sir.
All right. So we begin our lesson and looking at the lesson overview and then the objectives. We go through the overview of the lesson first. Please, you need not write this one. I will tell you what you have to write alongside. Now, in this lesson, we shall be looking at the following. And the first on the list is the meaning of matrices, what a matrix is. And then we'll also look at the various types of matrices. You know, we have several types of matrices, but at this level, we shall consider a couple of them, those we will need. Addition and subtraction of matrices is also going to be considered. We also be looking at the multiplication of a matrix. Multiplication of a matrix. When it comes to multiplication, you know, we can multiply uh, 2 by 2 matrices, 1 by 2 matrices, or matrix and a column vector, and all those stuff. We shall go through all those things this morning. Determinant of a matrix, we shall look into that. The inverse of a matrix, and then Cramer's rule. Cramer's rule. So these are the main things we shall be considering in our lesson this morning. Now, going through the objectives, by the end of this lesson, we hope that every one of you will have some knowledge on matrices. Again, you should also possess some knowledge on matrix operations. And then finally, be able to use matrix as a tool for solving linear equations with 2 or 3 unknowns. So, ladies and gentlemen, here we are. Let's keep the ball rolling. Matrices. What is a matrix? So, I'm a macho courage. Can you tell us what a matrix is? What you know about a matrix?
Said matrices are numbers arranged in rows and columns.
Oh, okay. All right. Seke Benoni, what do you know about matrix? Do you have any idea?
No, sir.
Yeah. Do you have any idea?
No, sir.
Oh, okay. All right. Precious. Awaga, please, I want to see your picture. Let the video work on the video, please. Chantal, what is a matrix?
So,
Yeah.
matrix is a rectangular array of numbers.
Oh, okay. All right, that's fine. Uh, I called Chantal. Yes, Chantal, can you give us or tell us what you know about a matrix?
Yes, sir. I said it's a rectangular array of numbers,
Oh, okay.
usually encased in parentheses.
That's good. Okay. So, yes, you are all right. So, this is what we have. A matrix that is singular. In plural, we say matrices, is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. So when numbers are arranged in rows and columns, we say it is a matrix. Now, the numbers, the symbols, or the expressions in a matrix are called its entries or elements. So, like you said, Chantal, they are enclosed by parentheses. So, the members in that bracket are the elements or the entries. You can also call them members. Now, we have the horizontal and the vertical lines of entries in a matrix. And the horizontal lines are called the rows, and the vertical lines are also known as the columns, respectively. For example, the dimension of the matrix below is 2 by 2. So I will be showing you a matrix, and we'll see what is there. Because there are 2 rows and 2 columns. Okay, so this one, let's consider this matrix. The matrix A equal to, now, 2, we have the 2, 5, 7, 8, 9, 3. So under the 2, the numbers under the 2 are in columns. The numbers under the 2 are in columns. So the 2, the 7, the 9 is a column. The 5, the 8, the 3 is also another column. So we have 2 columns here. Now, if you consider the horizontal axis or the horizontal line, then we have 2, 5, 7, 8, and then 9, 3. Now, all the numbers there are also in row. Let me show that pen. Let me show that to you. Well, pen. Yes. Yeah. Mhm. So, like I was saying, all the numbers I've circled here are in columns. Then when it comes to this side, we have another column. So we have 2 columns here. Then again, we also have 3 rows. That is considering the horizontal line. We also have now the whole of this as a row. The one I'm circling with the red ink is a row. That is one row. We also have another row, which is the 7, 8. Also another row. We have the 9, 3 also being another row. So we call this, when you are reading the values or you want to read a matrix, you tell us the order of a particular matrix, we mention the row first. So the number of rows we have there is 3, and then the number of columns there is 2. So we say that this is a 3 by 2 matrix. Again, we go to another one. Animal. Okay. How to move? How to move? Okay. Now, the matrix B we have here has also uh, 2 rows and then 3 columns. The rows, if you consider the horizontal line, we have 3, 4, 0. That is one row. Then the second row is 2, 1, 7. And the columns, if you consider the vertical axis, we have 3, 2, 4, 1, 0, 7. So we say this is a 2 by 3 matrix. Size of a matrix. Please, is there any problem with this? Awaga, do you understand the little explanation I've given?
Yes, sir.
So can we proceed?
Yes, sir.
Okay, thank you. Now let's look at the size of a matrix. So we say the size of a matrix is defined by the number of rows and columns that it contains. Now, a matrix with m rows and n columns is called m by n matrix, while m and n are called its dimensions. So, like the previous matrices, you can tell the dimensions of the 2 matrices above. For example, the matrix A above is a 3 by 2 matrix, and the matrix B above is also a 2 by 3 matrix. Now we move on to types of matrices. Maxwell, can you mention any types of matrix? Maxwell, do you know any type of matrix? Maxwell, are you there? Precious, can you tell us any type of matrix you know? I, yes, Precious, we are waiting. Hello. Kumi Monica. Kumi Monica, can you tell us any type of matrix you know?
The column matrix.
A column matrix, that's right. Rejoice, can you also mention one? Please, I didn't hear you.
Okay.
Oglovo Adam, can you mention one? Oglovo Adam, can you mention one?
Zero matrix.
Zero matrix, okay, that's fine. Emmanuel Edogake, can you also mention one? Yes.
The row matrix.
Okay, row matrix. Okay, so yes, we can take it from there. I think it's okay. Now, the first type we have here is row matrix. Row matrix, and it is a matrix with only one row of entries or elements. For example, now we have the matrix B equal 2, 5. Now, this is a 1 by 2 matrix. You will see that it has only one row, but it has 2 columns. So we say this is a row matrix. We also have the column matrix. And the column matrix, we say it is a matrix with only one column of elements. For example, we have the matrix V 1, 0, 3. And this is a 3 by 1 because it has 3 rows, that is considering the horizontal line, but 1 vertical line. So we said this is a column matrix. Please, you can write this before we continue. If you are done writing, you let me know. Frank Nukunu, if you are done writing, you let me know. Did you hear me, Frank?
I'm done, sir.
You are done, eh?
Yes, sir, I'm done.
That's good. Precious, are you done
Yes, sir.
writing? Kuma Jasper. Kuma Jasper. Please, can you on your video? Yeah. We go to the next one, the null or the zero matrix. The null or the zero matrix. It is a square matrix in which all its elements are 0. Now, this means that all the members in this matrix are all 0. It must also be a square matrix, which means the number of rows must be equal to the number of columns. Then we say it is a square matrix. So 0, for example, we have the O here. This is a 2 by 2 matrix with each element 0, 0, 0, 0. Another one, we have the matrix O giving us the members 0, 0, 0 throughout. And this is also a 3 by 3 square matrix. Rectangular matrix is another example. And this is a matrix with different number of rows and columns. This is a matrix, or it is a matrix with different number of rows and columns. So, for example, this is a rectangular matrix. The name implies a rectangle, a rectangle. Now we have the matrix B, 3, 4, 0, 2, 1, 7, and this is a rectangular matrix of order 2 by 3. 2 by 3 because it has 2 rows and 3 columns. Also, another matrix A equal to 2, 5, 7, 8, 9, 3. This is a rectangular matrix of order 3 by 2 because it has 3 rows and 2 columns. Please, you can copy this before we continue. And if you have any question, you can also raise your hand so that we help you out. If there's any question, just raise your hand. Emmanuel Edogake, do you have any problem with the explanations I've given to these types of matrices?
So please, the network was messing around the time you were explaining. So please, can you take it again?
You did what? Please come again.
I said the network was messing around the like I mean from where the example is from for example 0 is equal to 0, the
Which one is
rows and
that?
the column here from that side. Can you please take it again?
Which type? Which type of matrix?
From where the example the 0 for where the example is 0.
Is it the null matrix?
Yeah.
Okay.
No, the 0 matrix.
0 matrix. Yes, that is the null matrix, right? So we said the matrix 0 here, the matrix O here has its element 0, 0, 0, 0. This is a 2 by 2 matrix because it has 2 rows and 2 columns. I hope you know what a column is and a row is. Okay, good. So the next one there is also a 3 by 3 and all its elements are 0. So we say this is a 0 matrix. So for a 0 matrix, all the elements will just be 0, and that is all. Edogake, are you okay? Okay, thank you. So, I'm a mature courage. Are you done with the writing?
Yes, please.
Okay, please, I'll be inspecting this note, so make sure you all copy it. All right. Precious, are you done writing? Precious. as if you have a problem with your connection. I can't hear you, Precious. I didn't hear. Kumi Monica, are you done writing?
Yes.
Okay. So now we move on to the other matrices. Square matrix. What is a square matrix? And a matrix with this is a matrix with the same number of rows and columns. If you have a matrix having the same number of rows and the same number of columns, we say this is a square matrix. For example, we have the matrix A equal 1, 2, 3, 4. This is a 2 by 2 square matrix. The matrix B is also a 3 by 3 square matrix. So you see that we have 3 rows and then we have 3 columns there. So we say that this is a square matrix. Do you understand, Edogake? Edogake, do you understand? Chantal, do you understand that?
Yes, sir.
Okay. Now, the unit or identity matrix. It is a square matrix in which every member in the diagonal is equal to 1, and every non-diagonal element is equal to 0. Let me take it again. It is a square matrix in which every member in the diagonal is equal to 1 and every non-diagonal element is equal to 0. Now, the diagonal there, if you pick the matrix, the unit matrix, so we use I to represent a unit matrix, and this will give us 1, 0, 0, 1. Now, the 1, 1 here is the diagonal. So you see that every element there is 1, and the other side, the non-diagonal elements are also 0. So we say this is a unit or identity matrix. We also have a 3 by 3 unit matrix where all the elements in the diagonal is 1, and the elements at the non-diagonal side is also 0. So we have a 3 by 3 unit matrix there. So a unit matrix is always a diagonal matrix. When any matrix is multiplied by a unit matrix, it results in the same matrix. So if you pick any matrix and you multiply that matrix by a unit matrix, your result will give you the same matrix in that same order. So if it is a 2 by 2 matrix multiplying an identity matrix, your result will be the same 2 by 2 matrix. For example, we have the matrix P. P is multiplying the identity matrix I, and your result is going to be P. So whatever P is, that is going to be your answer. It will be the same thing. Are you okay? Kudo da Queen. Are you okay?
Yes, sir.
Good. Apenyo Caleb, are you okay?
Yes, sir.
Good. Please write this so that we can continue from that. If you have any question here, you can also ask. I think we can continue.
Yes.
Yeah. Diagonal matrix. So it is a square matrix in which every non-diagonal element is equal to 0. So an example is here. So all the non-diagonal elements must be 0. Then we say it is a diagonal matrix. Now, the other elements may differ, but we make sure that the non-diagonal elements are all 0. Then we say it is a diagonal matrix, and it must be a square matrix. Infinite matrix. A matrix with an infinite number of rows or columns, or both, is called an infinite matrix. So these are some of the definitions that we need to know as far as our matrices is concerned. Equal matrices or equal matrix. Equal matrices. Okay. Seke Benoni, your hand is up.
Sir, please, I'm not done copying the
Oh, all right.
infinite matrix.
All right, I hear you. Quickly copy that and let's move. So we move to equal matrices. Two matrices A and B are said to be equal if their corresponding elements are the same. So whenever you have two matrices and their corresponding elements are the same, then we can say that the two matrices are equal. For example, if A, that's the matrix A equal to PQRS, the matrix B equal to TUVW, and A equal to B, that is the matrix A equal to B. Now, it implies that we have the whole of this matrix PQRS equal to the matrix TUVW. Now, if you compare their corresponding components or corresponding elements, we can say that your P in the matrix A is equal to your T in the matrix B. Those two elements are corresponding to each other. Caleb, are you okay?
Yes, sir.
Good. Now, the element Q in the first matrix is also equal to the element U in the second matrix. So we say they are equal because they are corresponding. Likewise, the element R in the first matrix is equal to the first element in the second matrix, which is V. So we have R equal to V. They are the same. So what it means is that if your R in the first matrix is 2, then your V in the second matrix is also going to be 2. Then again, we have S. The element S in the first matrix is also equal to the element W in the second matrix. So this is for equality of matrices. Let's pick another example. If a matrix A equal to 5Q R7, B equal T3 4W, and A equal to B, then by comparing their corresponding components, we have, the whole of this matrix A, which is 5Q R7, equal to the matrix T3 4W. And by comparing, we can say that your Q is equal to 3. I'm a macho courage. Can you see that?
Yes, please.
Good. Edogake, are you following? Edogake, are you following? I can't hear you, Edogake. Kumi Monica, are you following what we are doing?
Yes, sir.
Good. Now, so we also have R equal to 4 because R in the first matrix is corresponding to 4 in the second matrix. And the same is applied to W, equal matrices. Kudoda Queen, are you okay?
Yes, sir.
Good. Do you have any question?
No.
No question, right?
Yes.
Okay, I'll be asking you some questions very soon. Copy this quickly and let's move on to the other material. Are you following what we are doing?
Yes, sir.
All right. Are you done copying?
Yes, sir.
All right. Awaga Cromwell,
Sir.
are you done copying?
Yes, sir.
Do you follow the explanation?
Yes, sir.
Do you have any question?
No, sir.
Good. We can continue. Addition and subtraction of matrices. Let's see how we can add and subtract matrices. Please, now that we know the definitions, we want to start or begin applying them by using other operators. So, when two matrices are compatible, now, when we say compatible, it means that the two matrices have the same number of rows and the same number of columns. Then we say the two matrices are compatible. We add or subtract them by adding or subtracting the elements in corresponding positions. So, for example, if you have the matrix A equal the matrix A equal to A1, B1, C1, D1. Those are the elements of the matrix A. and the matrix B equal A2, B2, C2, D2. Those are also the elements of the matrix B. Are matrices. So if you have these two, now you will see that they are equal or square matrices. They are square matrices, 2 by 2 matrices. Then we can have this. A plus B, we can add the two matrices. So by addition, we can have A plus B. Now, A plus B, so you see we have the first matrix A1, B1, C1, D1, plus the second matrix A2, B2, C2, and D2. Now, if you continue, this is going to give us, now by adding their corresponding elements, you'll be having A1 plus A2. You see, the A1 here is corresponding to the A2 here. So we have A1 plus A2. Again, we also have another one, which is B1. Now, this B1 is also corresponding to B2. So we have B1 plus B2. If you go to the C over there will also give you C1. This C1 is corresponding to C2. So we have C1 plus C2. Now, they will all give you exact numbers. If you add C1 to C2, it will give you a definite number. So the A1, the A2, the B1, and the B2s and all those stuff, they are numbers we are dealing with. We shall be replacing those elements with numbers very soon. So this is for addition. We add their corresponding components. Let's go to the subtraction. The same matrices A and B, so A minus B is going to give us the matrix A minus the matrix B. So like we did for addition, we subtract their corresponding components or corresponding elements. So this is also going to give us A1 minus A2, B1 minus B2, C1 minus C2, D1 minus D2. This is the formula or the method for adding two or more square matrices. Hi, Bob Maxwell. Are you okay with this? Kuma Jasper. Did you get that? Kuma Jasper, are you there? Any question? Okay. Are you done writing? Caleb Apenyo,
Sir.
are you done writing?
Yes, sir.
Okay. Seke Benoni, are you done with the writing? Seke Benoni, I didn't hear you. Okay. Let's continue. Example. So we want to pick an example. The first example there. The matrices P and Q are given by that. So the matrix P equal to 5, 6, 2, 7. And the matrix Q equal 8, 4, 1, 0. Find P plus Q and P minus Q. Everybody should try that before we go through the suggested solution. If you are done, you will raise your hand so that I call to take your answer. Yeah, Tenu Courage.
So I have the matrix P plus Q to be 13, 10, 3, 7.
Okay, that's your answer. Hold on with your answer. Who is also done? Edogake Emmanuel. Okay, that's fine. Yeah, your hand is even up. Come again, please.
Yeah, 3 and 7.
Edogake.
Also had 30, 10, 3 and 7.
Okay, that's fine. Rejoice. Said them. Said them now.
So I had a matrix 13, 10, 3 and 7.
Okay. Now let's look, let's all compare our solution to the suggested solution. Yes, you can lower your hand now. Let's look at the suggested solution to this problem. So our solution is this. This is how we expect that you do it in an exam. So we have the matrix P plus Q equal to, so we have 5, 6, 2, 7 plus the matrix 8, 4, 1, 0. You see, the substitution, this gives you some mark. Now, this is going to give us, so we add their corresponding element. So you see that the 5 is corresponding to the 8 here. So your 5 plus 8, and then your 6 is also corresponding to the 4, and that gives you 6 plus 4. We also have 2 corresponding to 1, and that gives us 2 plus 1. And then your 7 is also corresponding to 0. So we have 7 plus 0. So if you simplify this, your answer will be 13, 10, 3, and then 7. That will be the addition of these two matrices. Second Benoni, did you get that? Second Benoni. Please, I say you should all start your video. Start your video. Go and click on your video, the symbol there, so that I can see your face. Yeah, Kudu the Queen. Did you get that?
Yes, sir.
Good. Are you done with the second one? The P minus Q.
Yes, sir.
What's your answer to that?
Yeah, I got P minus Q to be negative 3, 2, and 1, 7.
Okay. Just hold on to your answer. Precious. Precious, what is your answer to the P minus Q? Precious, I don't hear you. I don't know. It seems you have a network problem. Okay, so that is that. So let's go to the second part. The second part of the solution, P minus Q. So we do the same substitution, and by subtracting their corresponding elements, we have 5 minus 8, 6 minus 4, 2 minus 1, 7 minus 0. So if you simplify this, we have negative 3, 2, 1, 7. That will be your solution. So just compare that to whatever you have. Wherever you made a mistake, you correct it, then we move on. And Tiamwa Godwin, did you get that?
Yes, sir.
Okay, Chantal, did
So
you also get that?
Yes, sir.
Okay. Edogake, did you get that, Anzan? Edogake. Didn't hear. All right. So let's go to the second example there. Everybody is going to try the second example. Now, the matrices A and B are given by A equal to negative 4, 2, 1, negative 5, and the matrix B equal to 7, negative 9, negative 2, 0. Find A plus B and A minus B. Everybody should try that right now. If you are ready, you raise your hand. I'll call you to take your answer. Edogake Emmanuel, can you give us your answer? Okay, Chantal, give us your answer.
So I had 3, negative 7, and negative 1, negative 5.
Okay, that's your answer. Tenu?
Say the same thing. The
Okay.
matrix entries 3, negative 7, negative 1, negative 5.
Okay. Frank Nukunu. Frank Nukunu. Okay. Let's look at the suggested solution. So, yeah, as usual, A plus B will give us the matrix A plus the matrix B. Then we add their corresponding component to have this. Then your answer will be 3, negative 7, negative 1, negative 5. That is our suggested solution to this problem. Those of you who couldn't get it or who made some mistakes, you can check and then correct that. Then A minus B, also the same principle. Okay, Chantal, your hand is up.
Yes, sir. I got negative 1, 11, 3, negative 5.
Which one? Is it the addition?
The subtraction.
Subtraction. Okay.
Yes.
All right. Hold on to your answer. We will compare later. Benoni, yes, your hand is up. Benoni. Apenyo Caleb, can you give us your answer?
Yes, sir. So I had negative 11, 11, and 1 negative 5.
Okay, that's your answer. Courage.
Sir,
Yeah.
so the answer is negative 11, 11, 3 minus 5.
Okay, that's correct. So let's see. Let's go through the suggested solution. Now, yes, as usual, so we subtract their corresponding element, and this is your answer. Good. So all of you, you've done very well. That's good attempt. Example number 3. So this is a 3 by 3 square matrices. The matrix C and D. So if your C equal to the matrix that and D equal to this matrix, find C plus D. So the same approach we used for the 2 by 2 matrices, the same thing we are going to do to the 3 by 3 matrices by adding or subtracting their corresponding elements. Everybody should try this one. Tianwa Godwin, as I start your video, I want to see what you are doing. Just go and click on the video button there. Okay, Tenu, your hand is up, but hold on. Ogwefu, your hand is up, but hold on. Kumi Monica, you will give me the answer to this problem. Precious, be getting your answer ready. Yes, is that Kumi? Okay, Kudo Dakwin, give us your answer.
So 5, negative 1, 1, 0, 1, 0, and 4, 8, 0.
Okay, that's your answer. Good attempt. We will compare our answers. Yes, Rejoice, Sedinam.
So beside the same thing.
Okay. Sake Benoni. Sake Benoni, are you not done? Okay, let's look at our suggested solution to the problem. So we have C plus D equal to the matrix C plus the matrix D. Now we are going to add their corresponding elements. So if you add, now we know that the 2 here, this 2 is going to these two will add up to this 3. So 2 plus 3 will give us 5. Now, we also have the -1, which is also corresponding to the 0 in the second matrix. So if you add the 2, you still get -1. We have the 0 here. If you add this 0 to the 1 here, then that also gives us 1. So we've added their corresponding components to the first row. We come to the second row. We are going to be adding their corresponding component. So this 3 will add up to the -3 here, and that gives you 0. This 0 will also add up to the 1, and that will give you 1. The 1 will add up to -1, that gives you 0. Then the third row, if you pick the 2, is corresponding to this 2. So if you add the 2 together, it gives you 4. The 4 will also add up to this 4. And if you add them together, it also gives you 8. -3 plus 3 will also give you 0. So that is the solution to the problem. Who is having any problem here? Seke Benoni. Benoni. Please, can you hear me? If you can hear me, respond. Apenyo Caleb, can you hear me?
Yes, sir.
All right. I hope you followed the solution.
Yes, sir.
Good. So that is that. That is that. Copy that first. Let's move on. Okay, so if you are all done, let's proceed. Multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar. So let's see what we have. Scalar multiplication is where a matrix is multiplied by a single number. So when you have a matrix and the number is multiplying that matrix, we call that number a scalar. That scalar could be positive or negative. It could also be a fraction. Just multiply whatever you have which is outside the matrix by each of the elements in the matrix. Now let's look at the procedure involved. Multiply each element in the matrix by this number. So you just pick the number outside the matrix and multiply it by each of the elements in that matrix. That is all. For example, if you have a matrix A equal to PQRS, then we can have KA Now the k there is multiplying a. So this is equal to the k multiplying the matrix A. You see, we are now replacing the A here with the matrix, which is PQRS. And that will be equal to, so the k here will multiply each element here. So now k times p. K times p will give us kp. K times q will give us kq. K times r gives us kr. And then k times s will give us ks, where your k is a scalar. So like I said, the k there is any number. Let's pick an example to that. Example 1, a equal to 3421 and b equal to, please Caleb, can you mute yourself?
Yes, sir.
Okay. And b equal to 1212. Find 2a and 3b. Now, your 2 is the scalar. That's if you pick the 2a. Your 2 is a scalar multiplying the matrix A. So, let's check our solution. We have 2a, and that is equal to the 2 multiplying the A, the matrix A. The matrix A is 3, 4, 2, 1. And that will be equal to, so if the 2 should multiply the 3, then we have 6. If the 2 should multiply the 4, then we have 8. The 2 multiply these 2 will give us 4. The 2 by this 1 will also give us 2. So this will be the result if you multiply the matrix A by a scalar 2. Let's look at the second one. We have 3b, which means you are going to multiply the matrix B by 3. So we have 3 multiplying the matrix B, 1, 2, 1, 2. If you do that, 3 by 1 will give us 3. 3 by 2 will give us 6. 3 by this 1 again will give us 3. And then 3 by the 2 will give us 6. So your result will be 3, 6, 3, 6. That is your result to this problem. Rejoice, are you okay?
Yes, please.
Good. Edogake, do you understand? I'm not hearing from this gentleman. Okay, Kudo da Queen, did you follow that?
Yes, sir.
All right. Chantal, are you okay with the solution?
Yes, sir.
Good. Let's go to the second example. Example 2. If P equal to 5, neg 2, neg 1, 3, 1, 0, find 5P, which means 5 is multiplying the matrix P, where your 5 is the scalar. Try that quickly. Boglovo Adam, you give me the answer to this. Yes.
Sir,
Okay.
25 minus 10 minus 5, 15, 5, 0.
Okay. So We shall compare the solution very soon. Now, let's look at the suggested solution. So we have solution. So your answer, we have, if you go through all the necessary steps, then we have 25, -10, -5, 15, 5, and 0. That is our suggested solution here. At the end of this lesson today, I don't know whether you've been introduced to the Google Classroom. I'll be posting some assignment for you to solve and submit your answers or your solution for assessment. So you will write your full name on top of your paper before you answer it. I want solution with names. So let your solution come with your name so that we can track whatever you are doing out there. Now, we have some few minutes to go, some few more minutes to go. Example number 3, yes. So we have the matrix A equal that, and then the matrix B is also equal to 4, 2, 7, -1. We are finding 2A, 5B, 2A plus 5B, A plus B, 3A minus B. So let's try this. When we meet again next time, we'll continue from this place. So please, you can go ahead to read more on matrices. We'll be doing multiplication, finding the adjoint, finding the inverse, the determinant, and all those stuff. You can go ahead to read them so that when we meet, you have an idea of what we will be doing. So like I said, your assignment will be there. I don't know, please, can you all unmute yourselves? Have you been given any code for the EMAT?
No.
Okay, I'm sure, yes, you will be given very soon. So as and when you are given, just go and log onto it, get the assignment, and then do and submit it at the appropriate time. Is that clear?
Okay.
All right. Yeah. So let's end today's lesson here. We continue again next time when we meet. Tell your friends out there that the class is also seriously ongoing, so they can also come and then join the online classes. They shouldn't waste all the time at home. I wish you the best.